There are at least 3.5 million office workers in this country, 300,000 in the northeast alone. On average, they spend 16 years of their working lives in offices. Are we giving them an ideal environment?
We found that the conditions inside office buildings in Newcastle were worse in summer than those inside buildings in Aden.
Can Britain's white-collar workers put up with second-rate design?
One afternoon, when our technician went into the building in order to change the charts on our recording apparatus, he found that everyone in the office was asleep. This was because of the high temperature inside the room caused by solar radiation. People had taken off their coats, rolled up their sleeves, and settled down to an afternoon siesta. It wouldn't be fair to identify this particular building because obviously there are a considerable number of buildings of this type all over the country.
Here, the radiant temperature went off the top of a graph at 100 degrees between noon and 3:30. This was in an office in Newcastle. David Price, a heating engineer and one of the new Conservative aldermen on Newcastle City Council, gives his view.
I've read Mr. Hardy's report very carefully, and I'm most impressed with the thought that he's given to the subject. The report includes 3 case studies of high buildings in Newcastle. I've come to the conclusion that there are so few of these high buildings in the city that the tower block of the Civic Center must be one of them. If this is the case, then it's obviously my job as Vice Chairman of the Civic Buildings Committee to look into it.
It's certainly true that it would now cost about £40,000 to get the indoor temperature of the high block reduced to a maximum of 75 degrees in summer. The report of Hardy's investigation into summer overheating in modern offices has only just been published. It was sponsored by the Ministry of Public Building and Works and the Electricity Council. The Ministry wished to decide whether the government should discourage the building of glass palace office blocks. The 2.5 years intensive research behind this potentially explosive report has been carried out at the Department of Building Science at Newcastle University by Senior Lecturer Alex Hardy and Dr. Patrick O'Sullivan.
Broad conclusions of the report are that the office buildings in which summer heating is caused is due to, first of all, an excessive area of glazing, and secondly, to insufficient ventilation in order to extract the heat from the building that is trapped inside by the glass. This effect of the glass is called greenhouse effect.
In the northeast, at least so far, there have been few of the kind of towering greenhouses that are typical of the London city landscape. But things are changing. Gateshead is the site for a new complex of office accommodation to be developed by Greensit and Barrett, which will be one of the biggest in the whole region. Much of the lives of white-collar workers and their working efficiency lies in the hands of architects. It's obvious, therefore, that buildings should function properly, as well as being good enough artistic designs to win awards. Hardy's investigation is a follow-up to an earlier work done in London. This showed that 4 out of every 10 office workers interviewed in London said they were too hot in summer. 1 out of 3 said they needed artificial lighting at midday. In blocks sited in main streets, nearly 7 out of 10 complained of traffic noise. But before the Newcastle research, no one in this country had actually measured how much sun and glass can overheat an office.
When overheating occurs in office buildings, mainly due to sunshine getting in through the glazing, the office worker will normally take off his coat and roll up his sleeves. In other words, reduce the amount of thermal insulation he carries about in his body. When this proves to be inadequate, he may open the window, but find that by doing so he emits noise, or he emits fumes, or it's too windy and it blows the papers about. So he therefore closes the window and pulls down the blind. The result of pulling down the blind not only obstructs the direct solar heat, but also obstructs the daylight, with the result that he then switches on the electric lighting. In other words, he's choosing an artificial environment in contrast to an uncomfortable natural one. What is important is that we do not accept the measurements that are made by thermometers to say whether the conditions are right. If people complain, then the conditions are obviously not acceptable.
So one of Hardy's conclusions seems fairly revolutionary. If we accepted artificial light in daytime, we could make do with much smaller windows. But how did Hardy and his workers reach their conclusions? For such a detailed piece of research, a great deal of scientific equipment is necessary.
This is a model of a typical office. The probe placed inside the model on the desktop measures the amount of daylight. This is then indicated on the meter on the daylight photometer. The model shows a conventional daylit office and a dull area at the back of the room, as compared with the high brightness near the window. This model shows an office with permanent supplementary artificial lighting, known as SALI, in which the area towards the rear of the room is illuminated by electric light and the area near the window by daylight. This shows the same office with permanent artificial lighting, or PAL, in which the window areas are for vision purposes only, and the interior is illuminated continuously by electric light.
A typical daylit office block. This temperature graph of a daylit test office shows the white dots of the radiant temperature rising to 90 degrees at 4 o'clock. Now compare a block with permanent artificial lighting. With the PAL system of strip windows, the radiant temperature in the test office went no higher than 72 degrees.
Air temperature alone does not give an indication of thermal comfort, as the greatest proportion of heat lost from the human body is by radiation. Therefore, a black ball is used to measure radiant temperature. The environmental pole therefore measures air temperature at foot level, head level, and ceiling level, radiant temperature at head level, and relative humidity at head level, as the head is the greatest skin area exposed to the thermal environment. The measurements we took inside the occupied buildings were restricted to the northeast, where we were in fact measuring the external conditions simultaneously. If, however, we get the kind of overheating that we found in Newcastle, obviously the conditions in the southern part of England would be far worse. Our main criticism is that the function of a building is to provide a private climate for its occupants in relation to their needs. And most buildings today are not doing this. What they are doing is providing conditions inside that are far worse than those outside the building. Today, we can fly at 65,000 feet at supersonic speeds in an airliner in complete comfort. Surely it's possible, when we're stationary on the ground, to provide similar conditions inside buildings.
Are millions of pounds of public and private money being wasted every year on white elephants made of glass?
The difference between designing a good airliner and a good office block are enormous. An airliner has a limited range of design problems. It also has a static environment and a static condition of the human being in that environment. In an office block, we have a wide range of variables, a wide range of different types of individual who will be working in this environment and not just sitting in it and taking what comes.
One of the most adventurous buildings in the northeast is Norgas House, the award-winning headquarters of the Northern Gas Board at Killingworth Township in Northumberland. One of its most notable features is the vast amount of glass used in the design. How do the occupants feel about working in such a modern building?
When we first came here, it used to get very hot in the summer, but now we have a cooling plant in, and everything's just great.
I like this office. It's big, there's plenty of room. You can move around, you can look out the windows. In the afternoon when the sun shines through the windows, you can pull the blinds.
Well, compared to the last office, I think it's absolutely marvellous. It's much pleasanter, it's on a bigger scale, and the atmosphere is much better. And of course, I like the big windows there because I'm a keen fan of sunshine.
I like this office. It's big and it's modern, but sometimes it gets far too hot, and I'd much rather open a window than have air conditioning.
The architect of Norgas House, Gordon Ryder, talks about the practical side of designing office buildings today and the problems he faces.
It is undoubtedly true that less than 1% of the new buildings going up today have air conditioning systems. I think it's also true to say that within 10 years these buildings will become obsolete. They will be generally unacceptable. And I think the most important thing is that it will be very nearly impossible to make these buildings suitable. It will be very nearly impossible to install a proper air conditioning system in them. As to whether too much glass has been used in Norgas House is a $64 question. Basically, what prompted the general design, the exterior design of this building, was the external environment. As you know, Killingworth is already a very beautiful place. It has some excellent views over a lake and a very pleasant landscape that will get better as the town develops. We are designing a new office building in the central area of Killingworth in association with Mr. Gazzard. This building will be in many respects similar to Norgas House, but in fact, as far as glass is concerned, it is totally glazed. The whole face of the building is of glass.
Another eye-catching building in the northeast is the physics block designed for Newcastle University by Sir Basil Spence. This up-to-date home for academic white-collar workers was one of the buildings examined in Hardy's report. Here too it is the glass which catches the eye.
The actual detailed test work was done on the 6th floor of the physics building, where we measured the internal conditions continuously over a period of a year. We also measured for shorter periods the conditions in the adjacent agricultural building, which had a different orientation.
Sometimes, particularly in spring and autumn, if the sun is bright, we can get, some of the rooms on the south side can get too hot. But this is within our control. We have got blinds we can draw at times like this, but only if we forget to do it. Some people find the air a little bit too dry. We only have filtering and heating. We don't have any air conditioning. And if there are only a few people around, this can mean at times the atmosphere is a little too dry for comfort for some people. But most people are quite happy about this. And the auditorium also, without air conditioning, it really is a bit difficult in summer with a large audience. But the building as a whole we're very pleased with, particularly for teaching and research, our main activities. The services supplied are very adequate, and they do help us a lot to give very good teaching and to keep our research going very happily.
As we have seen, there are overheating problems with Newcastle's new £5 million Civic Center, palatial symbol of the would-be Brasilia of the northeast. The architect, George Kenyon, talks here of some of its virtues.
In the final phase of the Civic Center, which in the main comprises committee, council suite, reception area, advantage was taken of the fact that these were to be air-conditioned, and hence, without any great additional cost, was possible to incorporate air conditioning into the office section of that portion of the building. If full air conditioning were to be incorporated in the first phase, as is in the final phase, this would have cost some £50,000 as at that time, which on today's prices, of course, would be considerably higher.
It's worth remembering that while air conditioning would have cost another £50,000, the cost of the Civic Centre's Caroline Tower was nearly £70,000. The city architect is also concerned with another new office scheme in the city centre.
Well, in the development of the Pilgrim Street roundabout, the corporation are sponsoring an office block that, though actually spans the north side of the actual roundabout and takes into account the restoration of the Royal Arcade. It is appreciated that the traffic circulates around this particular building, and to overcome the difficulties of the noise factor, it is the intention to employ double glazing throughout, as indeed is the case of the Civic Center.
Obviously, if a building such as this were to be designed in the center of a major city on a very busy bus route, one would take very serious notice of the amount of glass to be used in the building. We can overcome reasonably effectively the problem of sound penetration by using double glazing. But this, of course, is a very expensive operation, and it still doesn't make it completely satisfactory.
There's a difference between working in a multi-storey office block in the middle of a roundabout surrounded by traffic and working on an office block in the middle of a green field beside a lake.
Not all the people who have to work in the Newcastle Civic Centre are happy with the success of the building's design.
As chairman of Newcastle branch of Nalgore, it's been my misfortune to be on the receiving end of many complaints since the building was occupied some 3 years ago. Unfortunately, up to the present time, some of these still remain unresolved.
My present discussions, or the present discussions in local joint committee concern the inadequate ventilation and the overheated offices. The stage we've reached so far is that we've got the consulting engineers back into the building and they are preparing a report to the employer. As far as the poor lighting in the offices is concerned, this is being tackled a little piecemeal at present, we think. Some offices have had supplementary lighting put in, some haven't.
American office block design could affect British buildings in some odd ways.
In America, the first 10 stories of a skyscraper have no air conditioning. Everybody works in perspiration. This encourages them to move 10 floors up into the middle band, which has air conditioning. This air conditioning has no refrigeration, and it cannot be controlled by the individual. So the incentive there is to move a further 10 floors up until you get to the top, to the penthouse region, where you have personally controlled individual air conditioning with refrigeration.
One piece of research, however detailed, can't give all the answers to the problem of designing a good office environment. But it's equally clear that poor design must have a bad effect on national productivity and efficiency.
The relationship between the conditions inside offices and productivity cannot be measured because there are a wide number of factors that affect this. The only thing that can be said about this is that if people in offices are uncomfortable, then they won't work very well. The question of summer overheating is not obvious because out of doors in this climate we don't normally suffer overheating. And the other thing is that architects normally do not occupy the buildings they design, and therefore they don't experience the conditions that result from their design decisions.
With 3.5 million white-collar workers, this is a vitally pressing problem. Hardy's report documents some of the scientific evidence, and when we think of modern office buildings, he makes some startling points.
Even if you use air conditioning or special types of glass, you still cannot use the very large areas that you see in buildings today. If the building is of heavyweight construction, then the maximum amount of glass that you can use, if it is single glass, is 50% of the external area of any particular room, or 40% if it's double glass. If you use smaller areas, then you can control the situation by mechanical means. The reason why there is a difference in the area between single and double glass is that double glass will accentuate the summer overheating problem due to it retaining a great amount of heat inside the building. If a building is of lightweight construction, however, the area of glass mustn't exceed 20% of the external wall of any room if it's going to be possible to control the thermal environment and avoid summer overheating conditions.
I would like to think that the university will keep projects like this going, because I'm quite sure that research like this is very valuable and could well affect the shape of future high buildings.
But general improvement in offices depends equally on making good use of existing knowledge.
If an architect doesn't know how a building works, he's no good reason to be an architect. We should know the physical properties of the buildings which we are building.
Both the earlier report on London and Alex Hardy make the same point. Too many modern offices fail to shut out excessive noise, light and heat. In this respect, it is extremely doubtful whether today's average office building is better than or even equal in performance to the best of those built before the war.
And unless we have a very close cooperation between all the people who make contributions, we will find that we will continue to make a great number of mistakes.
15 years ago, I was involved in the design and construction of an office building which, when it was complete, was occupied by clerical workers, some of whom literally fainted with the heat and the oppressiveness of the environment. We recommended that refrigeration should be installed before the office block was completed. The employer wouldn't agree to this, but he agreed afterwards because he was a responsible employer, and it cost us many thousands of pounds over and above the original estimate to put in the refrigeration than it would have done had we put it in at the outset.
How much longer will a large number of Britain's white-collar workers continue to be broiled in brand new offices?